All right, so I'd like to describe now ELC 343 Lab 3. This lab involves the character LCD and switch debouncing. You're going to create a user interface. You present basically a simple message on the LCD. One challenge with that is that the LCD can only display 16 characters horizontally at a time. And these messages that we want to display are longer than that, so you need to come up with some way of dealing with that. You wait for a button as you're displaying this message. You wait for either switch 2 or switch 3 to be pressed, and when they are pressed, you immediately go into another message that says program completion succeeded, and then you can wait in that state for an infinite loop. There is a part 2, and I'm going to demonstrate going directly from part 1 to part 2. The part 2 procedure says that you'll be prompted to push a button, either switch 2 or switch 3, either button, and depending on which button you press, it will increment a counter for each button, and it will toggle an associated LED light on the display. And the challenge here is to do switch debouncing. And to do switch debouncing, so what is switch bouncing? Switch bouncing happens when the contacts of the switch, when the contacts just are like on the atomic level, the two contacts are coming into proximity to each other. You see that that there is kind of a non-uniform connection of the contacts and a merging of the contacts, and you get a phenomenon called bouncing, where if you looked at the voltage on the pin of the chip, you'd actually see the voltage bouncing on and off, high and low and high and low, and voltages in between, voltages that won't be read necessarily as a clean high or a low. Of course, in software, you'll always read a 1 or a 0, but inside the hardware, you can actually get non-binary levels. And switch bouncing can be a hassle. You may have seen keyboards that occasionally one button creates multiple unintended presses. Well, the challenge here is to make sure that each time we push the button, it only gets viewed as being pressed once. And the key to that is when we detect immediately, as soon as we detect the button down, either button down, we immediately take the action to handle that button down request. We update the LED state, we update the LCD display state immediately, but then we wait. We do a debounce delay. We wait around 50 to 100 milliseconds. That's plenty of time in order for the switch to settle out. It's also fast enough that if we want to press the button rapidly in succession, we probably would be able to still do that. And after we wait that 50, 100 milliseconds, then we can check the switch again. And now we want to wait until both buttons are up. We want to wait for a button up event. And once we detect that both buttons are up at this point, then we have to wait a second time. So you have to wait after the original button down to make sure you're not seeing bounces of up, down, up, down. And then when you finally see the button go up again, you have to wait again, because even though the button went up, it could have gone up, down, up, down. In other words, the button was open, the switch was open, but it might still be bouncing. So you have to wait, you have to make a time delay after each one of those, or else you'll see a problem. All right, having said all that, let's take a look at my project. If we look at my schematic, I have, again, I'm just showing the LEDs and the resistors that are on board. These resistors limit the current. The LEDs themselves drop about 2.1 volts. And the assumption here is that the supply voltage, the pin voltage here is 5 volts, although the boards can be set for either 5 volts or 3.3 volt supplies. Either way, you'll get enough current to light the LED, but you might want to assume that the high voltage, when a logical 1 appears at the output of a pin of the chip, it'll be driving roughly 5 volts. And then my switches, just like we had before, these switches have to be configured with resistive pull-up, or else they'll be just floating when there is no input. And I think that's all there is to say about the schematic. And of course, there's the character LCD display that we've had before. If we go to, oh, maybe we haven't had it before, right? So if we go to my main, one of the things you'll notice is in main, we have to call a start method for all of the, well, most of the components in the PSOC library. Pins, we don't have to call start for, and some other devices, but many of the devices we have to call a start method. We do it just once. and then we go into our infinite loop. I use while one for my infinite loop instead of the for that PSOC originally creates. Also, you'll note that I've gotten rid of all the boilerplate, so that you see none of the comments that PSOC stuffs in there for a blank file. I get rid of all those comments. The only comment that I keep is I've kept this one line, the global interrupt enable, and I keep the comment that they put because it's an appropriate comment. All the rest of the comments are not needed, and you should delete all of them and only keep your own comments. You can also see my code is fully commented. My code is neatly organized and very readable. You use vertical spaces to help make things more readable. You bunch certain things up to keep them logically connected, just like you'd write with paragraphs and so forth. And you can see I've tried to line up my comments also quite evenly. It just makes it less confusing for someone who's trying to read your code, and gives it a professional look. I'm not going to walk through my code. I'll let you sort of figure out how you want to do the code. But like I said, there are the two parts to this. And I think that's probably the main thing I want to say. I guess I'll just mention that you will be using, I recommend use the sprintf, subroutine that exists. It's a standard C subroutine. In order to use sprintf, you need to include stdio.h, the standard IO library, or well, it's really the header file for the standard IO library, and sprintf is part of that. Sprintf, you give it a pointer to an array that's allocated. So I allocate an array with 17 elements. 17 because the length of the LCD line is 16 characters, and you need an additional character location to hold the null termination character that terminates a string. So I make it 17 long. I sprintf, I use formatted printing to get the what I want there. I use a number designator that defines how big each of these fields will be so that things line up exactly the way I want them to. All right, I think that's enough for now, and let's have a look at the results of that. So it's printing out my, my initial message. It has the message on the top line. I just scroll through kind of slowly, and then it prints the message on the second message on the bottom lines, plus a switch to continue. When I press a button, it gives me that program completion succeeded, and then I immediately move into the next phase of the project where it says press either button, press either button, press either button. So it just keeps going on and on and on forever. And now it's going to be waiting until I push the button. If I push this button, it turned out that LED and it gave me an extra count. If I push the other button, it turns out that LED. And you'll notice that each time I push the button, it gives me exactly one count. It never gives me 2, it never gives me 0. If I hold it down, I get exactly 1. As soon as I push the button down, instantly the LED responds, the display responds, and actually I stopped scrolling the display. That's sort of a side effect of how I wrote my software. But it immediately updated things, and it never bounces. It never gives me 2 presses. So I press once up, once down, and it always counts as 1. It doesn't give me 2 pushes. Even if I press fairly slowly, it just ticks up by 1 each time. All right, and I account for the switch 2 and switch 3 and so forth, and that's all I'm looking for. So I think that does it. Good luck with this project.